This is a multiple-choice question designed to test your understanding of the GridSearchCV object in scikit-learn. It focuses on the attributes of this object after it has been fitted to data. The question presents 4 statements about the object's attributes, and you have to identify which ones are true. The core of this problem is about understanding the functionality of the GridSearchCV object. Specifically, it's about understanding what information is stored in its various attributes after you've used it to tune hyperparameters of a support vector machine, SVM. It's a great way to assess your grasp of the GridSearchCV tool in the scikit-learn library. This is the overall theme of the problem. We're going to be exploring the key attributes of the GridSearchCV object, attributes like "best _estimator _", "best _score _", "best _params _", and "CV _results _". Understanding these will help you use this powerful tool effectively. This statement refers to the "best _estimator _" attribute. After running GridSearchCV, this attribute holds the entire fitted SVM model that performed best across all the hyperparameter combinations tested. It's already configured with the optimal hyperparameters found during the search. The "best _score _" attribute stores a single numerical value, the best cross-validation score obtained. This score reflects the model's performance using the optimal hyperparameters, averaged across the folds of cross-validation. For example, it could be the highest average accuracy. This statement focuses on the "best _params _" attribute. This attribute is a dictionary that tells you the precise combination of hyperparameters, like C and gamma for an SVM, that led to the best cross-validation score. It provides the recipe for recreating the best performing model. The "CV _results _" attribute provides the most comprehensive information. It's a dictionary holding the scores and other metrics for all the hyperparameter combinations that were evaluated during the GridSearchCV process. Think of it as a complete log of the search. This is the core quiz question. It asks you to identify which statements are true about the attributes of a fitted GridSearchCV object after using it to find the best hyperparameters for a support vector machine, SVM, classifier. The question focuses on understanding the meaning and use of specific attributes of the GridSearchCV object, such as "best _estimator _", "best _score _", "best _params _", and "CV _results _". This attribute refers to the best performing SVM model. Best _estimator _ provides the specific model, with optimal hyperparameters, that produced the highest accuracy during the hyperparameter search. This attribute holds the best cross-validation score obtained during the search. For instance, if accuracy was being maximized, this would show the highest accuracy achieved among all hyperparameter combinations tested using cross-validation. This attribute gives you a dictionary. This dictionary contains the optimal hyperparameters which produce the highest cross-validation score. The key value pairs in this dictionary represent hyperparameters and their optimal settings, like C, 10, gamma, 0.1. It directly tells you the best settings for your SVM. This attribute is a treasure trove of information. It's a dictionary holding all the results from the hyperparameter search. It includes the scores and hyperparameter settings for every combination tried. This offers a detailed view of performance across all settings. This attribute is like a treasure map. It points directly to the best combination of settings, hyperparameters, for your support vector machine, SVM. It's a dictionary, a key value pair, showing you exactly which values of parameters like C and gamma gave you the highest accuracy. For example, it might return something like C, 10, gamma, 0.1, telling you that a regularization parameter, C, of 10 and a kernel coefficient, gamma, of 0.1 produced the best model. Think of this as a detailed report card. It's a comprehensive dictionary containing all the results from your hyperparameter search. This includes scores and settings for every single combination it tested. It's super helpful for deeper analysis and for understanding the performance across the entire search space, not just the best one. This is the star of the show. After the search, GridSearchCV gives you the actual, fully trained SVM model that performed best among all the combinations it tried. It's ready to be used for making predictions on new data using the best settings found. This refers to attributes or properties of the GridSearchCV. Object in Scikit-learn, a powerful tool for hyperparameter tuning. It's like a toolbox that helps us find the best settings for a machine learning model. Think of it like this. We're trying to bake the perfect cake, and the GridSearchCV is the recipe book that helps find the best combination of ingredients, hyperparameters, to get the best cake model. These attributes store the outcome of this search, providing insights into what we learned. This attribute returns the best performing machine learning model that we found during the search. It's already configured with the optimal hyperparameters, so it's ready to be used for predictions. It's the best cake recipe we found. It's like having a recipe book that has highlighted the best recipe based on what we tried. This attribute gives us the highest score, e.g., accuracy, F1 score, achieved among all the models tested during the hyperparameter tuning process. It's the taste score of the best cake. A higher score means a better model. This attribute stores a dictionary that lists the specific hyperparameter values that resulted in the best model. These are the ingredient amounts that gave us the best cake. It provides valuable information on what worked best. For instance, it might tell you the optimal value of C and gamma for your support vector machine, SVM. This attribute contains all the performance scores of all the different hyperparameter combinations that were tried. Think of it as the entire tasting notes of all the cakes we baked. It's like a complete summary of the results, not just the best one, allowing for a more thorough analysis. This attribute is like a treasure chest. It holds the results from every single combination of hyperparameters that were tested during the GridSearchCV process. It's a detailed record showing the cross-validation scores for each combination, so you get the complete picture, not just the best one. Think of it as a comprehensive report card for all the hyperparameter settings examined. This allows for a more thorough analysis beyond just identifying the best set of hyperparameters. This attribute points directly to the winning combination. It's a dictionary that gives you the specific values of the hyperparameters, like C and gamma for our SVM, that resulted in the highest cross-validation score. It's like a treasure map pinpointing exactly where the best settings are located. For example, it might say C 10, gamma 0.1, showing that C equals 10 and gamma equals 0.1 were the magic numbers for your model. This attribute gives you the star of the show, the actual best performing SVM model itself. It's not just the best hyperparameters, but the entire trained model ready to make predictions using those optimal settings. Think of this as the champion model that emerged after all the evaluations. You can directly use this model for predictions on new data. This attribute tells you how well the winning model performed. It shows you the highest cross-validation score, like accuracy, that was achieved by the best model. It's the numerical representation of the champion's performance. This provides a quantitative measure of the model's performance.